In this module of Chapter 2 on life tables, Module 2.8, I briefly describe applications of the life table method that can be used to analyze different types of single decrement processes. The general concept is applied to processes that can be dichotomized as entry-exit concepts. For example, being alive is the original state and exiting life by dying is the transition out of the live state. The same process can be applied to marriage. A cohort of newlyweds transition forward either by staying married or exiting through either divorcing or becoming widowed. Likewise, life table methods can be applied to childbearing, in which the radix is a cohort of childless women. These women transition to their first birth, or they exit if they remain childless. Women who have one birth can then transition to a second birth or exit as a one-child mother, and so forth. This table gives an overview of many examples of single decrement processes that can be studied by means of a life table. Again, the starting application is to mortality, the original application. The radix is the number of persons alive. They either survive forward or die at each age. Another example is nuptiality, where the radix represents the number of persons never married. These individuals move forward in this state by remaining never married, and they exit this state by marrying. These same processes apply to migration from place of birth, that is, movers and stayers, by entering the labor force, becoming a mother, subsequent childbearing, marital survival, unemployment, incarceration, diapause and hibernation, sexual maturation, reproductive parity, and flowering. In short, virtually all processes involving the transition into or out of different states of existence can be analyzed using life table methods. This not only includes processes involving single decrement transitions as outlined here, but also those involving multiple decrement processes that I cover later, where there are multiple ways to exit a state. For example, exiting the live state through different causes of death. Here I present an example of the life table method applied to professional soccer, in which the birth is when players are drafted into the league and death is when their last contract ends. This is a life table for 1,100 professional soccer players. This first column contains the year of play from the first through a maximum of 12 years. The next column contains the total number of players out of 1,100 that remained in the professional league by season. This next column I show is equivalent to the QX, which gives the probability of a career ending. This last column contains expectation of the number of years remaining in a career given the time in the league. Notice here that there is a relatively constant remaining expectancy in the league of about 2.5 years every year for the first 6 years. Here is a graphical representation of selected data from this previous table. On the x-axis is year of play. On the y-axis for this main graph is survival in league, a pattern that is distinctly geometrically decreasing. The inset shows the probability of exiting the league by year in the league, equivalent to QX. This ends Module 2.8. In the next module, I will describe how the life table can be used as a basic population model with zero population growth rate and some of the interesting properties of this model.